Hi friends, today we are going to see introduction about theory of elasticity. What is mean by elasticity? Elasticity is the ability of an object or any material to resume its normal shape after being stretched or compressed. In simple terms, for example, consider an element or object which is subjected to a mechanical load. Due to the load, the material may undergo deformation. Either it may stretch or contract. When the load is being removed, that particular material should come back to its original position or the normal shape. If so, the material is said to be elastic. Basically, theory of elasticity is a branch of solid mechanics or strength of material which deals with the stresses and displacement in elastic bodies, which is produced by external forces or due to the changes in temperature. And the main objective of studying theory of elasticity is to check the sufficiency of the strength, stiffness, and stability of the material, or to find the capacity or ability of the material to withstand the mechanical load without failure. The important aspects, concepts, or terms to be noted in theory of elasticity are external forces, internal forces, or stresses which is caused by the external forces, and the deformation. In simple terms, stresses and displacements. There are two kinds of external forces actually. One is the body force and the another one is surface force. Body force is mainly due to the center of gravity, the mass due to gravity, or weight due to gravity, or simply the self weight of the material acting on its own center of gravity. And the second one is the inertia forces due to the movement in the bodies or movement of the objects. The second one is external forces or surface forces. Surface forces mainly due to pressure. For example, pressure exerted on any body due to the atmospheric pressure in the air, or fluid pressure. When the body is kept underwater, the body may experience the pressure due to the water. And the second one is contact forces, which is mainly the external forces, mechanical loads, loads due to external objects or external bodies. As we said earlier, internal forces are nothing but the stresses created in the body due to the external forces, and the deformation is simply the change in the shape of the body or the change in the geometry of the body. Thus, it can be classified into strains and displacements. You know very well, displacement is the change in position of the body, and the strain is the resultant of stress. So it explains the deformation or defines the deformation of any body due to the external forces. The basic assumptions which we made in theory of elasticity are the body must be continuous, means it should be free from voids, cracks, and discontinuities, flaws, and it should be perfectly elastic since we deal about elastic bodies as the subject rightly says, theory of elasticity. The body must be elastic in nature, and then body must be homogeneous and isotropic. So, which means whichever the direction you choose, irrespective of the direction, the material properties must be seen within the object, and the displacement and strains must be very small or negligible. Some of the applications of theory of elasticity, we see designing the mechanical parts, elements, all the materials, stress calculation in beams, bars, columns, uh, and the stress concentration factor. Stress concentration factor mainly, um, as you see, involves in finding the stresses in the elements. For example, if you see here, So this is the specimen with uniform cross section, so uniformly distributed stress. Okay, the lines mention the stress flux, imaginary lines of force. And the second specimen, if you see, we have a void or discontinuity or a hole. So due to the hole, the stress distribution has a disturbance over here. Due to that, we have a stress concentration in the corners, so which leads to critical stresses. So at these corners, the stress will reach a critical value, and which may lead to propagation of the crack or hole, which may further lead to failure. So theory of elasticity helps you to understand the stress concentration areas, to identify the critical stresses, where the critical stresses occurs, so that we can design and manufacture safer components. So these are the applications of theory of elasticity, and that's all from today's class. So the remaining and we'll see the detailed applications and other aspects of theory of elasticity in our upcoming classes. Thank you very much.